Thanks all. So guys, yesterday we talked about Spark architecture, right? The details of the Spark architecture. So what we'll do today, we will just go through the things that just brief to the things that we covered yesterday, right? And then we will today we will go on a Spark transformation and action, right? And other details related to that. So let me present my screen. Okay, I'm sharing my screen. Guys, yeah, hope you can see my screen. So now guys, first of all, yesterday we talk about this architecture, right? I give overall idea that how things happen in a Spark. Let me maximize this. Okay. Uh-huh. I will just quickly be brief through, right? So in Spark, whenever let's say, so basically in Spark we have one cluster, right? We execute your entire job on some cluster. That cluster could be the Yarn, Mesos, right, or Kubernetes. In our case, we took Yarn as an example, right? And let me take a marker. Yeah. In our case, we took Yarn as an example. So when you install all the softwares and library, right, in this cluster, you will get libraries like Spark, Yarn, right? Then JVM and other things. Then you will get the resource manager, right? And the node manager. What's the job of this resource manager and node manager? Resource manager is the central point, guys, who basically is the manager, right? He knows what are all the resources it have in this cluster and how many memory and RAM everything is available, right? In my case, in this example, I create each VM with 100 GB of RAM, right? 100 GB of RAM, 20 cores, and 400 GB of storage, right? That way, in total, my cluster got 1 TB of memory, 200 cores, and 4 TB of storage. Now, this cluster knows each VM that information about each VM, that how many storage is available, how many memory, how much memory is available, how much cores is available, right? And based on that information, then it give tasks to this basically it passed the task to the nodes and all, right? So what happened exactly when you submit your job? So right, let's say the developer come and developer execute a one command, right? Spark submit. He gave the cluster mode as a yarn and right, and he gave all the resources. I need a driver of 20 GB. I need a port number of executor memory. I need of 10 GB and executor cores need at 12, 12 executor cores in each VM, right? When user submit this job along with this code, and this is an example, not py, right? When this user submit this job, right? What first of all, it would go to the resource manager. Now resource manager is only concerned about the amount of driver memory it need. So let's say it need if it need 20 GB of memory, right? What it do? It create one container process. Okay, that is a container process with the 20 GB of memory. What is a container process? It's nothing but the JVM process, right? And when that JVM process run, so right, because Spark is written in Scala and Scala run on a JVM, right? So it creates JVM process. Now, guys, your code is written in PySpark, right? How the JVM process know what is there in PySpark? With the help of wrapper that Spark developer build. What this wrapper do? It create the main method for your code internally so that it can execute it code. Okay. Now this with the help of Java wrapper, maybe your code might have written in Python, but it understand what it's doing. Okay. It know, okay, this person asked 20 GB of let's say memory for executors, right? executor memory of 10 GB, and number of executor is core, and this is his example.py. So what it do, then it asks to resource manager. Now resource manager, because he cannot create the executor process, right? Because he don't know how many executors, core and memory available across the node. So he contact to the resource manager. Now he means nothing but the application master, right? When you launch your container inside any one of the node manager, right? That container is nothing but your application master, and that's also the driver in case of cluster mode. So this application master or driver call to the resource manager and ask where are these resources available. So this means I need these resources. Now resource manager know, okay, you need 4 executor, right? So these are the 4 executor, let's say he would give, right? In each executor, he would give the 10 GB of memory, right? And in each executor, he would give the 12 cores, right? So in each executor, he will give the 12 cores to you. Now, what happened? And this is when it's running executor, that's also the container, right? It spawns this container over there. Now the piece of code that you have written get submitted across all the executors, okay, along with the partition of the file. Because when you are loading any file, that file can get placed anywhere, right? In this node, this node, this node, and this node. When you are running this piece of line, it first of all take all this data in the form of partition in these executors, okay? Once it got those partition, it start processing that, right? And these executors, right? This executor work on those partition, transform data, and then after transforming, it respond back to your driver, which is application master as well, right? Now on a driver side, I told you, if you apply, let's say your file is big enough, right? Some terabyte of data. And if you apply, let's say collect is an action, right? Then you might get out of memory error because your driver don't have enough memory to handle that much of load. So generally what people do, people sync that data at some other place, right? It could be S3 or anywhere, or even this cluster itself. So that's how generally in organization, people, what we do, we process data and store it into the another node, right? Let's say in any node in this cluster. So of course you don't need to give the node and all, you just load data into the cluster. Now there would be another process which take data from that cluster and do further transformation. So that's how generally in project you would you would see how transformation and other things happen, right? Now, okay. Now when I'm talking about the partition, guys, I told you that in here mostly the partition size is 128 MB block, right? So when you are loading the file of 5 GB, you will get the 40 partitions that way. Okay, if you do that math, right? And now see, in your case, you have 48 cores, right? Because 12 cores in each VM. When you are loading this CSV file, right? When you are loading this CSV file, it create the uh, 40 partition for that file, right? And you have 48 cores. Then what happened, guys? It would run all these 40 partition in parallel and then process that data. So you see that though you have huge partition, then still you can process the data on one go. Now imagine, guys, if you have some more partitions, right? Let's say you have the file of 7 GB and it have, let's say, roughly 70 partitions, for example. When you are, let's say, when you upload this file, this file might have, let's say, 70 partition CSV file. Okay. Currently I give the 5 GB, but it could be, let's say, 7 GB, right? And you uploaded that file. And then since it's have the 70 partitions and you have only 48 core, right? How Spark process that data? Spark, first of all, process your 48 partitions, right? And the remaining partition, it will just be in queue. And the moment, let's say, new, the moment, let's say, current process finish, then it would start the new, it would take the new basically partition which are available, right? So that's how, guys, Spark process your data parallelly and subsequently. Let's say it complete all its partitions. Let's say you give, let's say, 70 partition, so it will and but you have only 48 cores, it will start processing 48 core at a one point of time, and then other would be in waiting queue. Okay, and the moment your current task get finished, it picked up the task or partitions which is available in queue. So that's how it's processed data, guys. And then I also told you that when you are, I showed you on Spark, you are right, whenever you are running any Spark code, it divide into the job, stages, and task. Each action, right? Each action, like show, the common action I showed you, right? Each action such as, let's say, collect, for example, right? Or count, those sort of things, or show, these sort of things are the actions, right? So for each action, one job would get created on Spark UI. And then on each job, you can have one or multiple stages, right? Each white transformation result into the separate stage. So whenever you're doing white transformation, right? Like let's say group by, right? So before moving to these things, guys, when in this code, when I'm doing, let's say, transformation, right? First of all, white transformation, sorry, narrow transformation happen on a same executor only, right? So let's say in this executor, I got some data. Uh, what this particular piece of line is doing, it taking the department and ID and salary and filtering based on the column salary greater than 50,000. It apply and it have that partition, right? It have that, let's say, 10 partitions. It will apply this logic on the 10 partition that it's have. Okay. And would process the data. But in this case, no shuffling is happened because that partition have all the data that it need. But the moment you do the group by, right? Because now it may be possible in this node, you might have data for both engineering and HR department, right? And this node also might have data for engineering department, engineering and HR department. But since you need to do group by, you cannot do group by, half group by over here and half group by over here. You need to combine, let's say, you need to move all one department data into one executor so that you can apply group by, and that time shuffle happen. What it do internally, when it's a group by operation, it move all the, let's say, HR department from here to here, right? And all the engineering department from here to here. That's how they shuffle data. And the moment you do shuffle, guys, then the stage would get created. Of course, in each job, you will be having one stage, plus the moment you do shuffle, it would get stage by stage with this shuffle, right? So I just shown for one job, you have one stage, but it can be one or many, right? But one is repeatedly will be having. And for each stage, you will be having one or more tasks, right? Based on the number of partition that you have. If you have, let's say, 10 partition, 10 tasks could get parallelly execute, right? But at least one task should be definitely there, but it's completely depend on number of partition that you have. Okay, so that's how Spark would process this data in the stages, task, and job. The job, stages, and task, right? This is what we cover, guys. And then okay, now, guys, I will take you through some other, no, any question, guys, before I move? Okay, I will take that as no question, but just ping me or just unmute yourself if you guys have any question. Okay. Now, guys, when you are submitting your Spark job, right? I told you it create the stages and Spark job stage and task and how this executor, how this entire process work, right? But apart from that, there are a few other things as well, right? That you need to know. For that, let me share my presentation to you. Okay. So, okay, you can see my presentation, right? Now, guys, understand now this. Oh, okay. The when you, because from the interview perspective, interviewer wanted to know in how much the detail that you know about Spark programming and how things happen internally. Okay. I showed you guys this data frame and all, right? If you see, if you see in our earlier this piece of code, this is nothing but the data frame only. When you see this thing, for example, right? These are all the data frame, guys. You are creating the Spark data frame. Today we will be covering detail on this data frame and all, but these are all the data frame, right? Narrow data frame, right? What is data frame basically, guys? When you are, let's say, reading the file, right? You will get data in some form, right? That data is nothing but a data frame. Now on each data frame, you are applying some operation, let's say select, right? Filter. And after applying each operation, you will get some data frame back. Then on that data frame, you again apply other operations like group by, right? Average. Whenever you are doing any transformation, you will get back one new data frame, right? So these are all the data frame. And finally, you do action. Now, let me go to that PPT. Okay. Now, guys, the moment, let's say you have any data frame, right? Data frame, dataset, SQL, anything. Dataset and SQL, I will talk, but let's take this example with the help of data frame, right? What happened? You pass the data frame, but you pass that SQL code, but that won't run as it is, right? What happened? First of all, that piece of SQL, whatever, sorry, the piece of data frame that you have written, it convert, first of all, it get converted into unresolved logical plan. What is the meaning of that? Second. Okay. What is meaning of this unresolved logical plan? Guys, when you are loading any file, it creates some, it just vaguely know that what are all the high table references, right? It not know the detail about the table, how much GB of data that is having table, because whenever you are writing any SQL query or any data frame, right, you are giving location of one CSV file, right? And CSV file might have some columns, or whenever you are writing data frame, you might be connecting to one table, right? The table might be having some columns, table might be having some data. So first of all, it create the plan in a such way that it don't know anything about that table location, the type of schema that it have, right? It don't know anything. It just create one logical plan. Okay, these are all the table that I need to point to, or CSV file I need to point to. And then what happened? Your Spark catalog do analysis on that piece of code that you have written, right? So piece of code, like let's say you are reading, your data frame is reading data from CSV location or databases, right? It create the, it Spark catalog understand that thing. Okay, you are reading data from the CSV or table, and then it create the resolved logical plan. What is the purpose? What is the meaning of this resolved logical plan, guys? It it define the schema. Okay, it knows what is the, basically, your file location. What is the data type it have, right? Is it the CSV type or it's a database type? How, what is the schema that it have, right? All this plan would get created, because when things are running internally, it need to know that what is there, right? It is a CSV file, it's a table, it's a table with how many columns, right? How much data. So it creates some plan with the help of Spark catalog, right? once this plan got created, then there is a catalyst. What is the purpose of this catalyst? Guys, when you are running one piece of code, right? Whenever you are running piece of code, there are, let's say you have one problem, right? Multiple people can solve the same problem in multiple way, right? But there, we generally follow some good pattern, right? Let's say you shouldn't take big O notation, if you guys know, right? You shouldn't take too much time to process your data, right? O n square we talk, right? Or let's say you shouldn't apply for loop within the for loop, right? Or there are many basically good patterns that, right, when it comes to the programming, right? Basically design principle and big O notations. So if you are written, let's say, something not in better way, it optimize that logical plan so that there would be no more cost on a cluster side. Cost in the sense the memory cost and CPU cost. One of the example I can give, let's say you are writing some data frame or SQL, right? Now, guys, if you are, let's say, uh, it's called the predicate push down, but what is the meaning of it? You should apply first filter, right? And then do rest of the operation on top of that. So let's say select star from where I wanted to apply on only I want to do transformation on only department data. I have, let's say, one employee CSV that I just showed you, right? There is a department column there. I wanted to apply transformation only on a department things, right? Then why should I load entire CSV, do all the operation and then filter by department? First of all, I should filter the thing that I am more focused into. Okay, my main focus is on department. Let me filter first that, and then let me apply transformation. That's a simple one of the very simple example, guys. So it's called the predicate push down. You filter what are all the things that you need first, and then you apply your logic on top of that. Not like you apply entire logic and then filter at the rest, because that way you are applying your logic on whole data set, and your de- department data might be very few MBs, right? So that's how it optimized internally with the help of Catalyst, right? Now, once it got logical optimized logical plan, what it do? It create the multiple physical plans. You just need to know high level. What are all these physical plans? These plans are nothing but, okay, which cluster it should go, right? How much memory it should take, do it need to go to the this cluster or that cluster, right? These are all basically physical, because when your code indirectly get execute on this physical machine, right? And when it get execute, it have some cost associated with it. Which cost? The memory, CPU, all this cost. So it select the from the multiple, it get a multiple physical plan, and from those multiple physical plan, with the help of cost model, it select the best physical plan, right? So based on that best selected physical plan, what it do? One second. Notice. Yeah. So based on this best select physical, once it got the best physical plan, it execute that on a cluster with the help of IDD. So because I told you, right, anything you write data frame, right, it eventually convert into the IDD. So with the help of best physical plan, then it execute that best physical plan on cluster, and you would get the result on your local, or sorry, on your, let's say, driver, or you can even load data into the sync. It could be S3 or in the same storage itself, same cluster itself. So that's how, guys, this entire flow happen when you just run Spark submit command, right? I showed you that architecture diagram, but these are all the things also internally happen when you are running your piece of code, right? Now, let's say, guys, there is further more, right? Now, let's say it execute the IDD, right? Then now I showed you it convert the thing into the stage AS and task. How that happen? Let's see that one that one as well, right? So we are good here till right. It create IDDs. Now let me go to the next thing. At the moment you create the RDD, right? The moment, let's say, you create any data frame, I told you that it eventually boils down to the RDDs. It create the resilient distributed data set, right? Why it called resilient distributed data set? Because it's, let's say, this RDD is like, let's say, if you have any, if you have created any RDD and by chance, and when you apply another transformation out of that, it RDDs are immutable. When you apply any transformation on top of that, it would create the another RDD, right? And then you apply another transformation on top of that, it would create another RDD. But your earlier RDD would be still there. In case, let's say, your latest RDD got failed, but still it can recover itself from the past stress, that okay, okay, this was my last successful stage. So that's why it called resilient. And of course, data is distributed. That's why it's a distributed data set. So RDD and data frame are nothing but the same. Means data frame, eventually whatever data frame you are writing, that eventually get converted into the RDD only, right? So whatever RDD, right? So you are executing this RDD, right? Now what happened, right? You have, let's say, RDD over here. Then guys, this RDD get passed to your DAX scheduler. What is the purpose of this DAX scheduler? It split your basically DAG. I showed you yesterday in yesterday's call, right? There is a DAG, direct acyclic graph. Someone has to schedule it, right? Before running, someone has to schedule it. So there is a DAX scheduler, right? Which take that DAG and split it into the stages of task, stages and task, right? So I earlier I mentioned, right? Each your job gets split into the stages and tasks. So basically, that stages and tasks who create is what your task scheduler create. Now, once your task got created, someone has to execute it, right? So who execute it? It's your executor execute it, but executor by default don't know that how which task I need to pick. So task scheduler, which is a cluster manager in our case, resource manager, we also talk to it, right? We also call it as a resource manager as well. That resource manager know which task need to execute at which location. Okay. So this cluster manager or resource manager pass this task to respective executor. And then this executor work on that particular task and piece of data frame. So you have a piece of task, that is code, and piece of data and partitions. On that, your worker thread run and execute task. So that's how, guys, this end-to-end flow happen when you run your piece of code on a Spark. Let me go to this. If you are, I hope you are clear about RDT point. So now, guys, let me show you that things, data frame. Nice. So guys, whenever you are writing any data frame, right? These data frame and all, these data frame are nothing, this DF, right? Or let's say narrow data frame, wide data frame. All these data frame will get eventually converted it into the RDDs only, right? So this is what only the RDD I was talking about. Okay. Now let me talk some more detail on this RDD, because I told that all the data frame will eventually get converted to the RDD, because Spark don't know big. Spark work on a low level API, that is RDD. So let me talk few point on RDD, and then maybe we can go do some other hands-on things. Okay. So I told you that all the data frame that you are creating are nothing but the eventually get boils down to the RDD, because Spark work at a low level API, which are RDDs only, right? So what are RDD guys, right? It's immutable. I told you that from one data frame, you create another data frame, right? And since it eventually gets converted into the RDD, it's the same, right? From one RDD, you would create another RDD, and that, let's say, right, let's say one RDD you create, let's say, to read a CSV file, and then another RDD you apply some transformation on top of that. On the same RDD, then you again apply group by. So after each transformation you will get IDD, but it preserves that earlier stage as well, successful stage as well. So the moment, let's say, your any IDD get failed, you will still have a way to recover. That's why it's called it as a resilient, right? And since data is distributed, right, you are working on a Spark distributed framework, so that's why it's a distributed, it called a distributed, and it's a data set. So that's how full form of IDD is, right? It's a immutable distributed collection, right? And then it support the fault tolerance as well, right? And parallel computing, because it's nothing but the RDD is nothing but working on your piece of, let's say, partitions. So it support the parallel computing to you. A lazy evolution, like data frame, right? The moment you take action, it would not process anything. It just create a tag, okay, until you take action, right? A transformation are not executed until action triggered, right? And it also allows some caching and persisting. We will talk it in detail. So basically, just to give the glimpse of it, when you are doing some transformation, right? Let's say, guys, you run 15 line of code, okay, on a data frame, and you wanted to store that data somewhere, right? Uh, so instead of storing, let's say, that data you need on a, let's say, every 30 minutes, that whatever the piece of 50 line of code you have written, maybe imagine that that piece of code take, let's say, half an hour to run, right? And that data, something that you need after every 1 hour. Let's say you have some job which running on every 1 hour, and that job need that data. Would you guys running that every 1 hour, that 15 line of code which take 30 minutes, right? And then collect that data. So best way is, guys, to cache that data. You can cache that data into the memory and disk, right? These are other options. The memory is the best way to cache, so that in next 1 hour, whenever I am running that piece of, my next job is running, I don't need to rerun that 15 line of code. I can just take data from the memory itself. So that's how this caching and other things work, right? And there are different caching level also available. Now transformation, right? I talk that it's a narrow transformation and wide transformation that you have. The way in IDD, there are some different method, map, filter, and other things. Mostly you will never get chance to work on IDD, but its knowledge is required at, okay, because it ultimately it's boiled down to the IDD only, right? And you have wide transformation as well. The way, guys, we have group by other things, it's the same like in IDD as well, but the functions and other things are different, but the underlying concept is the same. So it also have the narrow and wide transformation. And the in-memory computation, of course, because entire Spark is running on the in-memory, so that's why it's supported in-memory computations. Let me go to the next things. Okay. Okay. To summarize, guys, this entire thing, okay, whatever we talk, right? First of all, we talk about the architecture and all, right? And then this, I told you about dash scheduler, logical plan, and physical plan. So first of all, whenever you are running one piece of code, right, it create the logical plan for you, right? It represent that it don't know at this point, it don't know, uh, it purpose it represent what operation you perform, right? Let's say select, filter, without knowing how to perform them, right? That's the purpose of logical plan. Then you are having the optimized logical plan. Who, with the help of what you get this optimized logical plan? With the help of catalyst optimizer. I told you that predicate push down, right? It's like you apply first where clause and then apply transformation on top of that. It also do the constant. There are some this terminology, constant folding and all. I will cover in detail later part. But it apply best practices on top of your data, right? It's create a logical optimized plan, and this logical optimized plan, it pass to the physical planner. Okay. Now physical planner, what it do? It create it describe. Of course, it create the multiple physical plan and it select the best out of it. Okay, it describe how to execute your operation. how to do scan, how to do join, right? Because when you are doing join data which is spread across the executor, you need to your 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 physical plan see about the cost of doing it, right? And it apply the best strategy to do it, right? There are some, let's say join, one of the join I can tell you, for example, let's say you have two joins and one join is in one data frame, you have, let's say 1 GB, 1 GB of data, right? And in another data frame, you just have the, let's say 2 MB of data, right? Now, guys, when you are joining these things, you don't see, of course, join would do the shuffle, right? So in that case, it do broadcasting and all right. So that's what the physical plan. I will talk in more detail on this join and all, but it select the best physical plan so that there will be less cost on a cluster. And the moment now, guys, after physical plan, you get the IDD, right? Then what this DAG scheduler do? Because IDD, when you are running, it create the DAG, right? When you are doing transformation one by one, it create the DAGs, right? So this DAG scheduler, what it do, it execute your DAGs, right? And create stages of task. It basically build a DAG of stages and tasks from the physical plan. Whatever physical plan you have created, right? From that, it create the stages of task and stages and tasks basically. And then it eventually execute everything, data gets shuffled and all, right? So I just wanted to show this, how this entire thing related with each other. Now, guys, so this is enough on a theory side. Maybe now today I will go on data frame, right? Because we guys wanted to see how data frame work and all. So in my ID, PyCharm ID, I have did all the settings. I will show you one, I will create one document later to explain you guys how to do that. I would encourage you also people do the same step so that on your local, you can have IDD, you can have this setup ready, Spark setup ready, so that would be good for your hands-on activity. Okay. Okay, let me share my screen. Okay, now guys, I will take you to my Spark IntelliJ application. Okay. Okay. Let me share it. Now, guys, I have did this Spark setup on my local. Now I will be running some. We'll be creating data frame, right? And we'll do some row level and column level operation to start with very basic, and then gradually will increase the complexity of it. We create some. We will think about some use cases as well, right? So, guys, I have two data set. One is department and one is employee. Okay. Now let's say I wanted to read this data with the help of Spark. What I need to do, guys, first of all, so in Spark, the entry point to deal with your data is you need a Spark application, basically Spark session, sorry. Now, of course, to it show that it unresolved reference. So for that, you need to, let's say you will be importing some libraries, which is in this case, PySpark SQL. From PySpark SQL, you need to get this Spark session, then only it would run, right? So now what is Spark session, guys? Spark session is unified entry to interact with your all Spark functionality, right? Including, let's say, data loading, data frame operation, right? Anything that you wanted to do, for that Spark session is the entry point. Now, guys, let me load employee data frame, create an employee data frame, right? What I did, guys, over here, I use this Spark session object, read method I have called. I will explain this one line one by one. Then CSV is the one of the parameter, right? There, if you see, there are multiple parameter over here. It have schema, let's say ORC, JSON, and other thing. Since my file format is CSV, I will use CSV. There are table and other, there are tons of file option over here, right? When it comes to the read part, right? When you just click on it, it have multiple methods, right? So which method I am calling now? Currently read method I am calling. That's why I just give the read, and then I give the path of my file and header true. What is the meaning of it? I want whatever the file I am loading. Let's say this one. It should print its header as well, right? And then infer schema. By default, when you are loading any file, you have option to whether to infer schema or not. If what is a schema basically, guys? Let's say this is a date, right? Or this is, let's say, string, for example. I want Spark to take it as a string. Or this is, let's say, number. I want integer basically. For schema is right. Now, guys, let first employee data frame dot show. Let me run this piece of code. Let's. So this is how, guys. First of all, you will get any data frame and will show that on your local. Data frame with the help of show. It's the same, nothing but whatever it's available over here, right? The entire data you can see over here with the help of Spark thing. Now you can do further transformation and other thing as well, right? You can load multiple file based on your requirement. But now, for now, let's go with this. On this file, let's say, assume we wanted to apply some transformations, guys. So there are multiple transformation you can do. We will go first of all some basic column level operation and then basic low level operation. Okay. Now, guys, here, now, guys, let's say you have this data frame ready, right? And from here, you wanted to just see some columns. Maybe you have all these column in your CSV file, but you wanted to just see few columns. How you will be doing, guys? You will use this employee df, right? And then you can basically, let me just get this entire thing. You will use the select is a method, right? And then you need to give the column name in double quote. And that's how you will call you can call all the columns which are available in this particular data frame. Let's say you want one more column as well, right? For example, now let me run. These are very basic details, guys, but I just wanted to cover because there might be some people who might not know this nitty-gritty, right? So it would be good if we start from the scratch, very basic, and then we will be covering some use cases, how to generate the insight from data, right? That time maybe we will go on a direct implementation. So you see, I took first name, last name, and joined it. So whenever this is a basically guys column level operation. You wanted to let's say get only specific column from data frame. This is how you should do column level operations, right? On each, I told you, right? Data frame will get eventually boils down to the IDD, right? Output of each data frame is data frame only, guys. EMP let's say. And if I do the EMPDF dot show, this is also fine, guys. What you are doing over here, you are getting first of all data into the employee DF, and then you are showing that show method, right? Earlier, in this case, in earlier, I just apply show method over here. But if in case you wanted to get first data frame and then apply show method on top of that, that is also fine. Okay, just one note. Now let's go to the let's imagine that I have some data frame, right? And I wanted to add a new column into my CS, basically on the data frame. I read data from CSV, but I wanted to add new column. How we should do that, right? Adding new column is a common use case we generally do. Let's imagine you wanted to add new column with the bonus salary, and of course name of the column would be bonus. So how you will guys do, right? You will create the you will create the sorry you will create, guys, employee DF, right? Then which column is the method that you have? What's the column name you wanted to give? That column name, right? Post that. Of course, if you wanted to generate column name, you can generate that from the specific data set mostly, right? Right. So this is my current data set, employee DF, right? And here now, because I wanted to add a bonus column based on a salary, that's why I'm taking current column, right? And on a current column, I am applying some increment, for example. And then I'm doing, either I can do this way, EMP, let's say EMP bonus, right? And then I can do EMP bonus dot show. So what I'm doing over here, guys, I am adding new column. How I am adding? First of all, it's a column name you need to give. On which column you wanted to, from which column you wanted to create a new column. In my case, I use from the employee data frame itself. I have one column that is salary. On top of that, I am applying this logic and I am generating this new column. And if I do show now, it would run now. You see, we got the result. And if you just hover over here, you got the new column that is bonus with what are the logic that you apply, right? It create the bonus column over here. That's how, guys, be you can create a new column into your current data frame, right? Let me go to the third column level operation. Meanwhile, guys, if you not got anything or not clear, just let me know. I'm just Just showing one by one this thing to you guys, because it might be possible that some of you might not know. That's why I'm just repeating these things. Okay. Now, guys, let's say you have one data frame is there, right? Because when you are, if you are calling, if you are saying that we are data engineer, right? Your day-to-day job is, of course, you need to deal with Spark data frame, and you should know, first of all, minor, basically nitty-gritty of this data frame, right? How to apply the row level thing, column level thing, and then how to take advanced, then group by joins, right, across two different data frames, and then work on some advanced topic. So first of all, we'll go on a simple step, and then we'll move our complexity. Okay. Now let's say, guys, you wanted to rename one of your column, right? How you would do? You have employee data frame, right? Then with column, there are multiple options, right? With watermark, I will use with column rename. Then in this case, just give me, guys, 1 minute. Sorry, guys. So with column rename, right? I wanted to let's say rename any column. For example, I want to rename this last name column with L name. And of course, I can take data frame and all these things, but I will just do show on top of cancel L name dot show. Let me run this, guys. This way you can convert any column into the any let's say column name to any column name. There is a common requirement that, okay, you wanted to change the name of the specific column, right? When you're doing a data related operation. So this is how you will be using this with column rename method. And if you install this PyCharm ID and other thing, it even nicely show you that all the basically the method with the example and all, right, with the method input and output, right? What method existing expecting as an input, and what is return type, and some example the moment you over there. Now, guys, here you see, now I should have my last name as a L name over here, right? So this is how, if you wanted to rename any column, you can do this with the help of rename operation. Now, guys, imagine that I have a requirement to drop one of the column, right? So how I should do? For example, I wanted to drop column. The way I should do, let's say employee data frame, right? I will take first of all name of the our data frame, then drop. Okay, it show the column name. So which column? Maybe I can take in this case location as a column, and then we'll apply show method. you see, in our current data frame, we don't have the show column because we have dropped it from the our data frame, and in result, you not got that thing, right? So this is, guys, drop column is one of the column level operation that you generally do, right? Now, guys, let apply some filter. Let's say you have some data and you wanted to take only that data from this CSV. You loaded data into the data frame, right? And you want only those record for which salary is greater than 80,000. How you should do? Filter operation, right? I took first of all my, okay. First of all, I took my employee data frame, right? Because this is the data frame on which I wanted to apply transformation, right? Then I will apply the dot filter. What filter I wanted to apply, right? I wanted to apply filter on, let's say, employee data frame. Uh, I just need a salary greater than 80,000, for example. So what I'll do, employee df dot salary. Let me just do, because I have this plugin in, so it show automated. T. For example, I just want those employee having salary greater than 80,000 to show. Let me run it. And guys, what are the code that we are writing over here? Soon, maybe in upcoming session, we'll be writing the same thing in Databricks notebook as well, right? And even AWS Glue as well, right? But you imagine that, guys. I think salary, it's in lowercase. Let me just try. That's why we got this error. So if it show that data frame object has no attribute salary, right? Do you mean salary? It understand the current data set, and that's why it's prompting. Let's say I haven't yet seen the what is it's if salary yes is in lowercase or uppercase, but let's try it since it's recommending that. Now, guys, we'll be learning the same thing in Database Notebook as well and Amazon Glue as well, right? Earlier if you remember, guys, we execute this Spark related code in Synapse Notebook, right? So we'll be doing the same things on other environment, right? So that you know that how to code in those places, right? So you see, guys, now we got only that data where their salaries is greater than 80,000, right? All these things, as you see over here, right? Now, this is a filter. This is this sort of operation. It called as a filter, right? Now, guys, let's do the conditional filter, right? Maybe you if you guys know that, okay, there is a when clause in SQL, right? So what you do, you wanted to, let's say in our use case, you wanted to give the label as a high or low salary. Okay. So let's say you wanted to do, you wanted to add one, the use case talking about, you wanted to add one new column. Okay. That column name is level. Okay. And when employee data frame salary is greater than 80,000, you label that column as a high. Otherwise, you label that column as a low. I wanted to do that way, right? And when you, if you know, guys, that in SQL, when is a common one of the basically function that you generally use, right? When let's say salary is greater than this, then do that. When not, else do this, right? This sort of things. So we will show how to do those things in Spark data frame, right? So now, guys, as I showed you, the so we'll call this as a conditional column labeling, right? Conditional column labeling. Okay, you wanted to label that particular column. Okay, now let me, so where we wanted to label that particular column, basically on employee data frame only. Okay, so now let's take data frame, right? Since I wanted to create a new column over here, as I showed you in earlier example, you need to, if you wanted to add the new column on top of your current data frame, right? My current data frame is like this one, right? Only, right? I wanted to add new column on top of my current data frame, right? On top of this data frame, whatever I am having, I wanted to add another column. So I will give this column name as a label, let's say. Now, okay, I give the label. Now, guys, let's do when what I wanted to do, right? On what basis I wanted to give label? When employee DF, then I wanted to get the salary of it. Salary greater than 1,000. Then you mark it as a high. Okay. Else, otherwise low. Right, complaining for. So it when employee DF with column label I give with column label, then when employee DF dot, it should not show this error. Okay, got it. So possibly guys, we need to import few things for it. Let's see if that, right? The moment I import all, so these are the SQL functions, right? And when is one of the function from the SQL. So if you wanted to use that function, then you need to import right package for that, right? So the moment I apply import these things, this when error goes away, right? And that's how I got this data. Now guys, I created these things and I just wanted to now see how this data look like. Let's run this query to see if we get whatever things we want. Okay. When missing one requirement, what exactly is talking? So it's showing that when missing one requirement with the value, okay, when employee DF dot salary greater than 80,000 high, okay, I think I made mistake. High greater than 80,000 is high, otherwise slow dot show. Sometimes this auto pop-up make it's good sometimes, but it unnecessary confusion when we select any one of them. So now guys, let it try to run. Let's see if it gives us result that what we want. So in this case, guys, what we are trying to do, we are applying when condition, right? When employee data frame salary is 80,000, it should label, we are adding new column, but how we are adding new column? With the help of some conditions in our query itself. That's commonly you will do when you do operation in a data frame, right? So you see the moment, let's say salary is less than 80,000, it would mark it as a low, and more than 80,000, it would mark it as a high, right? So this is how functional conditional column labeling that you generally do when you deal with the data frames. Now, guys, let's do some string operation. Generally, what happened, you wanted to uppercase and lowercase data, right? The common thing that you do with data frame. So now let's what you wanted to you we wanted to, let's say last last time we wanted to make it as uppercase, right? So how we should do that, right? So for that, let's say string cases, I will just make it as, because whenever you are doing any string operation on the string, right? Lowercase, uppercase, so that sort of things. So I will choose your existing data frame, okay? And I wanted to add a new column, right? Instead of making changes into the existing one, I will add a new column, okay? I will give the name of that column as a, let's say, a last upper, for example, right? And then which column, right? I wanted to do into the uppercase, right? I will use upper function for that. Okay. Now on what I want to do upper function, it's the employee df last name. Df. Multiple way to do this, guys. I generally prefer this the approach to choose the last name in my data frame. I have the last name column, right? This I just pick this one for upper method I called, and in that upper method I'm passing employee data frame last name, right? Then I will just show these things. So what here we are doing, guys, we just add new column with the help of with column functionality. We add a last upper method, okay, and then we apply upper is one of the function, right? And in that function, I use or my which column I wanted to make it is upper. I choose employee df. Then last name is one of the column I choose, and then I apply the show method on top of that. So guys, when you are seeing this, right, though we are running locally, but when you will run this piece of code on your any cluster, right? This is my local setup. But the moment you run it on any cluster, what are all the things I explain you, right? That happen internally. It convert your Spark data. I mean, first of all, it's read, it know what are all the executor and all, right? Where is your CSV file is available, right? And executor, all these things would happen internally. But developer at least need to know, or architect need to know that you guys need to know what's internally happen, right? At architectural size, not just maybe at a very high level, you should have the information about it. So it happen all these things internally when you are running your Spark code. It even when you are running this data frame, I told you, right, it convert it into the RDD and it go to the logical plan, physical plan. All these things are happening when you run, will happen when you run it on cluster, and we'll be running those things on a cluster. But from for development perspective, you need to get more hands-on on the SQL. So that's why we are running these things over here. So you see, we got a last upper column with all the basically last name with capital, right? We convert entire all. So our last name is our column, and we can convert this into the uppercase. All these things, right? Now let's do some other column level. Sorry, operations. Now, guys, for example, I wanted to extract, let's say, year in my data frame. You see that we have some year column, right? Some date column, and I wanted to extract the year from that. How we should do, right? So let's do that. Employee data frame dot with column, right? Now, where I wanted to apply with column, let's say, I, be- so with column, tell that which column you wanted to create, right? So I will first of all will give some name to that column. So year, right? This is what the column name I wanted to give. Then I want to, there is a column I have, right? Join dates, right? I want to apply the year column, year function, right? On that join date column, right? Year function, year is a function from the data frame itself. You can call that, right? Then where I wanted to apply that year function, right? I want to apply year function on employee data frame. There is, it give me these things year, but I don't have that year column. I have this data frame column. Sorry, join date column. Okay. On this join date column, guys, I wanted to extract the year from it. Okay. Let me create the show. So I apply with the help of year. So in current data frame, I apply with column and creating the new column. So I should get the new column in my data frame. How I wanted to build the logic for that new column. The year is a function I apply, and on year function, what I'm passing, year function need one date. How I am passing that date? I wanted to see from that data frame, from that particular row, take the join date, right? And you apply year function on top of that. So for example, let's say on this row, you should see output as a 2018. For this row, you should see output as a 2019. But for new column, that is year. Let's see if that works that way. Okay, guys. So if you see, we got the year column added to the current data set, right? I have this join date, and on top of that, I create the new column year. And for each year, for each join date, I just extract the year, for example, here, right? Let's say 2020. From here, I just take the 20. 2017, I just took the 2017, right? So this is how you would do. You can just pick the specific column from your, you can just pick the specific column and apply some year function on top of that. As long as that year exists, it should be the date column only on which you will be applying this year function and all, right? Now, guys, let's move to some other things. Okay, date extraction we talk. Now we will talk about casting column, right? most of the time you wanted to cast one column into one specific format. Let's say you have some data in the form of float 10.5 or 6.5, right? You wanted to, and you, let's say when you do the infer schema, right? When you do the infer schema, Spark define its own schema for that. Maybe by, because it's Spark decided, right? So let's say it gives a string as a data type to your float variable. But now you wanted to give it as a, let's say, float or int, for example, right? There might be some integer column, right? Let's say this is salary is integer, right? And maybe by default, when you are doing infer schema, Spark, let me just print these things. I will show you that the moment, let's say you read any file, right? You can call the print schema just to see how Spark, when you are seeing infer schema, right? When you are telling Spark to infer its schema, what exactly Spark is inferring to. How we can check that with the help of print schema. You see what it did. See, for salary, it took as an integer, which is good case for us, right? But sometime what happen, if there is a huge data, and this way it's a good, right? It create a date. It consider join date as a date, which is good, so that you can apply date level function. Now imagine, guys, I seen some cases where in Spark consider integer also as a string, right? But so in that case, it's, if you apply some integer level operation, right? Let's say you wanted to multiply that particular integer with some number, right? The, let's say, the way we add bonus column, right? If your column infer by Spark as a string, and if you are applying the integer operation, string into integer, it will give error, right? So generally, what like recommend you should create the schema for your own. Maybe you should create a schema upfront. In maybe upcoming session, I will define. Currently, I ask to infer schema to Spark, but you should have complete control to define your schema. I will take another example, right, for that one as well. So now, okay, we infer schema, but still, in our case, it's taking salary as integer, which is good case. But in case Spark took that salary as a string, and we wanted to convert that into the, let's say, integer, right? How to do that? Let's say cast column, employee data frame, right? Then here, what I will do, guys, I will apply, let's say, I will create one column, let's say with column. I will give the name of the column, let's say, salary int, okay? And then what I will be doing, because whenever I am deriving one any column, I will be deriving from that current data set itself, right? Employee df, okay? Then here, what I will do, I will just take the salary, I think is the column name that I have. I'll just put it in double quote. Okay. Now on this salary column, what I wanted to do, I want to cast it is in integer. Okay. Dot cast. What casting I want to do over here? I want to apply integer type. And then finally I will do show. What I did over here, guys, with on employee df, I create the with column. We know that with column will give you one new column. What is the name of that column? Salary int. On a salary int, I what I'm doing, I took employee data frame only, and how I want to derive the logic for this column? I want my, for each row, whatever the salary column is, I wanted to cast it is into the integer, right? With dot cast operation, and data type is integer, right? And dot show. Let me run it. In upcoming session, guys, of course, role after completing row level operation, column, currently we are on column level operation. Then we will cover some other row level operation and some joins, complex joins. Then we will build some more complexity over here, right? So salary is a column, right? And I generate the salary int as a new column, but its data type is integer. Now in this case, luckily my string, my salary also have the integer data type, and of course, whatever the new column that I am deriving, right, with the salary int, right, that also data have the data type of integer only. If I just do print schema, you can see that both is having the integer as a data type. But in case, guys, imagine that Spark, because I know that inference schema is good for just testing purpose. Most of the time, you want the complete control of the schema of the file that you are reading, or the schema of the table that you are reading, right? You want, okay, this to be float, this to be string, this to be big integer, this to be unvarchar, sorry, this to be a string, right? So all these things you wanted to give specific information to your data frame, right? Just by not just by inferring things. So first name, last name. Okay, maybe what happened, guys, over here? See, I I run this entire show command, right? But I apply print schema on current data frame only, not the result of this one, right? So that's why we got a result. Ideally, why what we should do? Let's say this is a data frame, right? Either you can call print schema over here as well, right? Or just to make things more simple, right? Schema is a new data frame from every transformation. So these are the transformation only, right? No action happen. So on this schema, I will just do schema df, schema data frame. I will apply now print schema method. You see, I got now the salary also as an integer I got, and the salary integer also I got as an integer. Luckily, my salary integer in this case was the integer, but if it could have been in string, it might get it will get converted into the integer with the help of transformation that we applied, right? So guys, this is a transformation which you do, and the moment, let's say you do, let's say any dot collect, right? This is a action, or dot show, this is the action. And I told you, right, for each action there would be another one job get created. You transformation won't result into the actions. So what is the transformation in this case? So employee data frame with column is one transformation. Then you apply another transformation on top of that. You can do furthermore, right? You can then filter as well, right? With whatever logic that you wanted to do, right? So these are all transformation. Unless until you take any action, job won't get created, guys. So just to reiterate the last part, earlier whatever we discussed as well, right? So now, guys, next thing, casting of the column is done. Now let's say replace value. I wanted to let's say replace my Spark. So basically, let's say there is one in my Spark data frame. Let's say I have one column, location, for example, and No, not location. I think the city column there, I think we have. Let's see. Yeah, I have location column. Okay, sorry. So in location column, I wanted to replace, let's say, New York with some value, right? All the, let's say I have New York over here, right? I wanted to replace that with some other value. So how to do that manipulation, right? String manipulation. It's a common use case, guys. Whenever you are reading, doing data frame operation, you always do this sort of things. Now with column, then what I will do, guys, I will okay. In this case, maybe let not do with column, just maybe we can replace existing column only, right? I will replace existing column. Okay. And what I wanted to replace, right? I want to replace, let's say, this word, okay, with this word, right? And 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 from which column, right? A column name is location. Let me do show on top of that. So what I'm replacing, guys, this is mostly, guys, the replace value. Let's say from data frame, you want to replace some things, right? So first of all, what is the current value? What is the next? What is the value you wanted to replace and for which column? Let's see how this respond. You see all the NY location, New York location, it convert into the NY. So if you see in original CSV file, you have the New York at the first place and then at the fourth place, right? But it eventually replace all these things in your current resulted data frame output. So that's how, guys, you will use any replace value. Let's say you wanted to replace all a particular word with some look other value, right? So this is how you would be using this functionality. Now, guys, we talk a couple of row level operation. Now let's focus on a column level operation. Now let's focus on a row level operation as well, right? So now let's our earlier focus was on the row, on a column. Now till now, guys, we were mostly dealing with the column. Let's say with add new column, right? Replace let's say particular value. We are replacing some value, right? And then casting operation and other thing we talk, right? So now let's say how to do row level operation with the help of data frame. Okay. Now what a row level operation I wanted to do, guys? I want to order my employee data frame with the help of salary in decreasing order. Okay. Employee data frame, right? This is what the data frame I wanted to sort. Okay. Then I'll be using order by method over here. Okay. You see, guys, don't you see think that this and SQL things are almost same, right? But only that what Spark developer or data frame developer did, they create the functions for you guys so that you can just call this function. If you are not pro in SQL, you can call this function and get things done. And one of the good advantage you will see in later stage, you can see SQL. Of course, you can. SQL is I have seen this SQL and all with. let's say 1000 line of code, right? And not everyone would be able to write those SQL with 1000 lines of code, and it's difficult to grasp those SQL. But with the help of data frame, we can split your big logic into chunk of data frame, right? That's how main, I think, benefit of data frame. You can split your entire big SQL logic into series of data frames, and then get same result out of that, right? So just adding one point. Okay. So order by, right? Order by, what I'm doing, employee, let's say employee DF, employee data frame dot salary I want to do. Employee data frame, employee data frame dot employee data frame. Okay. Dot salary. Do I have salary? Okay, I have salary, right? Okay. So what I'm doing over here, guys, I am ordering my current employee data frame, order by how, employee data frame, salary, and descending. Okay. And finally, I am applying show on top of that. I will just again reiterate. You can even, when I'm saying, right, let's say C D F. Okay. Let's say I get this data frame, right? And you can even do show. So 10 is, guys, by default how many data frame you wanted to load, but I will just show, and I will not pass any parameter. How many record you wanted to, not data frame, how many record you wanted to see. In this case, I will not pass any argument. It will show by default 20. So you see, guys, now salary we got in descending order, right? You see, from 89,000 to it's in descending order, right? So this is how, guys, you can apply the row level operation on anyone, and right. So now let's see the another row level operation. For example, guys, you wanted to remove duplicate. Okay, let's say you have some. In this case, actually, there is no duplicate, but let's say there is a department and I wanted to remove all duplicate department, right? I wanted to remove duplicate on a department. And on which column? Department column. I wanted to remove all duplicate, right? How to do that? Okay, I will use data frame, right? My data frame, whatever I am having. Then there is function drop duplicates. Okay, I will use, let's say there are multiple. Maybe I will use exist whatever one that it's both are the same. Nothing but it's like, guys, they develop multiple methods. You can see multiple methods with the same, giving the same functionality. So I will use this one, right? So now, okay, I got this drop duplicate. Now on which column I wanted to apply duplicate, right? I want to apply duplicate. I want to do that on department column. Where is my department column? Department column, right? And then on a department column, I'll be using this. Let's say now do the show method. Let me run these, guys. So here what we are doing, we are removing duplicates, right? From the department column. Let me run. So today, guys, I'm just doing one operation and just showing that, right? Ideally, what you do, you apply transformation, then again transformation on top of that, again some transformation on top of that, right? And then finally you do action. So that approach will cover in later stage, right? Now see, I remove all the duplicate department. I just got four department in my output, right? Finance, HR, IT, and marketing, right? I have multiple those sort of things, but I just remove all the duplicates from my this implementation. Drop duplicate methods, right? Now we remove duplicate, right? Now guys, let's do if let's say you if you want to do group by, right? Now it's a okay, fine. We are doing it's on local. Now guys, this is till now we were doing mostly narrow transformation. Now it's a wide transformation we are doing. We are doing the group by. Okay. So what I'm doing group by on, I want to do group by on department, and let's have the count, right? Let me delete this. Group by. Okay. Just a second, guys. Okay. Fine. Let me do group by. Sorry. Yeah. So, so guys, we want to do group by based on department, right? So how I should do? Let me take my employee data frame, right? Group by on what I want to do, on what I want to apply group by. I want to apply group by on a department. I want to apply group by on department, right? Right now, and I of course when I'm doing group by, I should apply some aggregation on top of that, right? So some these are see you when of course I believe that you guys know basic group by and all these things, but just to give you quick things. In grouping, you group all your data. Let's say you have multiple department data, you group based on let's say HR, IT, finance, right, marketing. And on that group data, guys, on that group data, you apply your aggregation logic. That aggregation logic like get max salary from this, let's say get max salary from this group department, or let's say get average of salary from this group department. So these are all the aggregations, right? Mean, max, average, those things. Count. So we'll be using now count. So what we are doing, right? Doing guys, employee data frame group by department and then count and then dot, let's say show. I told you that show you can even call another the same data. You can call create another data frame out of it, and on top of that you can call show. But for now we will do this one. Let's see what result it will give to us. You see, you got a result for department and count, right? You apply the group by on department, and for you are getting the count of each department. For HR, I have five results, right? For finance, I have five results. Marketing, four. IT, I have six. This is how you do group by and count. Apart from count, you have also other these operations as well, which you can perform based on your, these are aggregation operation, what we call. You first of all, the basic fundamental in basic fundamental thing in group by and aggregation, right? You create the group of data from your data that you have, right? Group by department, it could be group by department, or it could be group by, let's say, region or anything, whatever the column that you have. And on that group data, then you apply your aggregation logic. What are all the aggregation logic? It could be sum, it could be average, it could be max, right? I need, let's say, max of population. If let's say you have region related data, right? And on top of that, let's say a region, in that region, I wanted to get regions with the max population, right? Or mean population, right? Or average. So those sort of all aggregation you can do this way on a group data. Okay, right. So we talk about the group by department. But I'm just showing at a very basic level now, because I think that someone who not know anything, for them it's important. And I will cover, we will move all this piece of code, we will learn all this piece of code in Databricks as well and AWS Glue as well, and we'll cover some more complex scenario. And that time maybe I will just take you through that. Okay, all the piece of code is available over there, right? But if I show that directly to you, you will not get what I'm talking about. That's why this one by one going to each transformation and action is important now. Though it may take some time, but it's important because next time, let's say when I'm learning running the same thing on Databricks, right? Maybe I will run the piece of code and I will explain you that piece of code, but it will be huge. It may be, let's say, 50 lines of code, right? At one go to explain to you. But to understand that 50 lines of code, you need to know this row one by one operation, right? Row level, column level, and other things. Now, row level operation we talk. Okay, we did the group by, right? Now, let's say guys, do another row level operation. We will group by department and take average of salary. Okay. So how to do that, right? Group by, and then what you wanted to do group by? You want to apply group by on department, right? It's auto pop-up, just ignore it. Okay, group by department. Okay. And then on department, you wanted to apply some aggregation logic, right? See, on a group data only, you can apply aggregation logic. Okay, this is our group data. You have some group data and you wanted to apply now some aggregation. What aggregation, guys, you wanted to apply? You wanted to get average salary, average of salary. So salary is another column. Okay, so salary is another column. And now on that, you would be applying show method. Okay. So what you guys did over here, you take employee data frame, you group by based on a department. I have department column over here, right? In my data set. And it contain IT, HR, finance, and other thing. So I group data based on a department, and then I apply aggregation function over there, because I'm on a group data only I can apply aggregation, right? And then I'm taking the average salary for this department. Let's show guys these things. Now I will just cover maybe two more transformations and that two or three, and then maybe we can have the if any question, and I will cover the other part in next sessions. So guys, you see department and average salary as a column name. uh, If you don't give any specific column name, it would take the same column as it is, right? So you see HR, this is average salary. Finance, this is average salary. Marketing, this one, and IT, this one. So this is how you would you can do the group by on specific column, or and on a group data you apply aggregation logic. So aggregation is a method. On top of that, which aggregation you wanted to do? There are multiple aggregation, right? So you can have max, right? Mean, average. all these things you can call based on your requirement use cases, right? Now, guys, fine. Now I will just show. See, sometime you wanted to. Yeah, let's say I have this group data, and I wanted to. I just wanted to talk on show operation, right? Let me see how many data. 21, right? I have 21. Now let me click employee data frame dot show. Let's see how many record it returned. Okay, 120, right? 120. Okay. In this case, I think it return all the data frame. But guys, generally, if you have huge data, let's say you have 500 rows, Spark would only return the 20 rows, right? Most, because of course, if you are, let's say, 500 rows and Spark, it's very unpractical in any IDE or any Databricks notebook or even on a Synapse. It would return you only 20 rows, right? Just for sample purpose. But now, if you wanted to see only, first of all, if you wanted to see all the rows, how you should do, guys? There is one option for here to, if someone asks, okay, how to get all the rows from data frame, right? Whatever the employee data frame you have, the count of it, it should show, it would show, sorry, whatever the employee data frame and that count, it should show all the row to you. So currently in our case, it's not more practical because I anyway have 21 row only. But if you, let's say you are having 500 rows, right? Rows, right? And you wanted to see all these rows, this is the way you should do to get all the rows from your data frame. And guys, a couple of my session would be on transformation only. This transformation and action only. We'll be covering more complex topics in upcoming sessions before going to the AWS Glue, Spark, and other thing on AWS also. I am having that Lambda and event driven thing, right? So before that, I wanted to spend more time because as a data engineer, your day-to-day activity is more on this side, right? So this is how it would be. Right. And finally, guys, I will just show now. Okay, I am having this returning this. You see, in this case, yeah, I told you, right? It won't matter because I anyway have less data in my data frame. So that's why it anyway would return anything. But if you want to show all the data, 500 rows, for example, right? You should use this approach, employee data frame dot count, and it should show you all the rows, 500 rows from your data frame if you have already in your CSV file. Now there is also one more operation, limit. You can even limit to the number that you want. Let's say I just wanted to get two record. Sometime what happened, you wanted to just guys see the sample of data, right? Whether, okay, you load that file and you wanted to see, okay, if my file got read properly or not, right? And you don't need to even load entire 20, though but it's a good design by Spark itself that they just load the 20 records only, right? But even if you want to do some limit operation, you see, why I not got any result, I apply limit, but I not did anything on top of it. Say, right? So guys, see, show is a action. Show is a action. DF limit, right? When I do this transformation, I got one data frame. On top of that, you can do action or do further transformation, right? So it's completely up to you. So the moment you do action, then only Spark would create a job. So now let's do this thing. I should show only two data frame, two rows to you guys. You see, guys, only 2 rows we got, guys. So, guys, there are other thing maybe we'll cover in upcoming sessions, right? Maybe one very final thing that I told you, right? Let's say you load this data, right? And you did some transformation on top of it. You use a very, I told you in earlier session, earlier call itself, right? Let's say you load one piece of data and you apply some, let's say you run 100 lines of code on top of that data frame, right? It doing some complex business logic, and you know that to run that piece of logic, you need, let's say, it took your Spark job took, let's say, half an hour. Now, next time, whenever you wanted to run, and your job is running after every 1 hour, right? That in every 1 hour, it of course it take 30 minutes to take that huge transformation, right? In every 1 hour, will you run that? And that's not, guys, dynamic data. That's static data, for example, right? Why to then every time get that data load, right? And do that transformation, though the data is static only, right? So what you guys generally do in that cases, you just apply cache operation. What this cache operation do, guys? It create that data frame and it load that into the cache, so that let's say your job is running on every 1 hour. Next time, and that data is static only, it will not load data and take half an hour to load that static data, right? And do some transformation and all, same transformation and all. You can just cache the data, and that data is available on that moment itself. The moment you call df dot whatever transformation, right? Let's say filter or anything, that whatever you want to do. So that's one of the option to load data into memory. Okay. So this is what I think maybe I wanted to conclude today's session with this one. We have a couple of more transformation and operation. Currently, today we are just dealing with only one file, right? Employee CSV. We will be in upcoming session, we will be joining the files, right? And grouping data and then aggregation and other complex operation, right? Those we will see, guys, in upcoming sessions. Today, for this is the first session, I just thought to go with the simple file, and gradually we will give the complexity and all, guys. And of course, we will move to we will run in upcoming section, we will run the same code on Databricks notebooks and other platform as well. Yeah, basically AWS Glue and other things. So, any question, guys, before I conclude this session?
No.
Okay. Thank you very much. Thanks for joining. I hope you guys, I will share you one document to do hands-on, basically how to do setups, okay, on your local. And I would say that I would encourage, that's the best way to, if you see, let's say you take any community edition, right, database community edition, you would do it's a free for 14 days, right? And then what happened after 14 days? You might not be able to run, right? Because it's a cost, you need to pay a cost. And for learning, generally people don't recommend, because if you are learning, why you should pay a cost, right? Just to learn, right? Maybe you can use some ID and you can forever learn free over there, right? So that's how why I am using this idea. We will cover other things in notebook as well. So yeah, I will share you one document, guys, how to do those things, setups and all. All right, guys. That, yeah. Anyone saying anything?
No, nothing.
Okay. Okay, then thanks everyone, guys. We'll see you in upcoming session. Thank you very much.
Thank you.
Stop recording.